This video will discuss MGSE 9 through 12 FBF3. Identify the effect on the graph of replacing f of x by f of x plus k times f of x, f of the quantity k times x, and f of the quantity x plus k for specific values of k, both positive and negative. Find the value of k given the graphs. Experiment with cases and illustrate an explanation of the effects on the graph using technology. Include recognizing even and odd functions from their graphs and algebraic expressions for them. In the high school curriculum, students will have multiple opportunities to investigate this standard, as they will address it in their study of linear, quadratic, and exponential functions. However, when exploring the transformations portion of this standard in the linear units of Algebra 1 and coordinate algebra, the expected focus would be on the vertical translations for linear functions, relating the vertical translation of a linear function to its y-intercept. When exploring the transformations portion of this standard in the exponential units of Algebra 1 and coordinate algebra, the expected focus would also be on vertical translations, but it would also include reflections about the x and y axis. Because linear and exponential functions do not provide ample context to address the odd and even functions portion of standard FBF3, this portion of the standard has been struck through and is not expected to be addressed in the linear and exponential units of Algebra 1 and coordinate algebra. When investigating quadratic functions in the quadratic units of Algebra 1 and analytic geometry, it is expected that all portions of standard FBF3 would be addressed. Quadratic functions provide good context for students to get a sense of the effects for each of the types of transformations mentioned in FBF3. Eventually, through work in later courses, students will need to understand these ideas abstractly and be able to talk about them for any function f. Quadratic functions also provide good context for introducing the notion of odd and even functions, allowing students to connect these concepts to their study of symmetry in earlier grades. These specific function expectations regarding standard FBF3 can be found in the course curriculum maps and unit frameworks for Algebra 1, coordinate algebra, and analytic geometry. In 6th grade, students work with collections of equivalent ratios and gain experience with tables and graphs and the correspondence between them. In 7th grade, students analyze proportional relationships and graph collections of equivalent ratios, determining these values lie on a line through the origin. In 8th grade, building upon their experiences with tables and graphs in 6th and 7th grade, students are introduced to the notion of function. They explore functional relationships algebraically and graphically and explain the correspondence between them. 8th grade students also begin their formal study of congruence and similarity, connecting these concepts with the properties of translations, reflections, rotations, and dilations. The 8th grade standards ask for the use of manipulatives to illustrate these types of transformations. In high school, students deepen their understanding of the correspondence between geometric transformations of graphs of functions and algebraic transformations of the associated equations. High school students are expected to develop fluency with linear, quadratic, and exponential functions, which includes the ability to graph them by hand, simple cases without technology, and more complex cases with technology. As previously stated, students begin their study of transformations of plane figures in 8th grade. They observe the properties of translations, reflections, rotations, and dilations, and gain experience with them by using physical models, transparencies, or geometry software. When introducing standard FBF3, exploration activities such as this one from Desmos can assist students in connecting their prior knowledge of plane figures from 8th grade to the transformation of graphs as asked of in this high school standard. Desmos is a free resource which includes an online graphing calculator, hundreds of digital student activities, and an activity builder to help teachers make the best activities for their students. In the following clips, students are using the Desmos Graphing Calculator app to help determine how changing specific values of the parent function affect the graph of the function.
So when you add it, it goes up, and then when you subtract it, it goes down, and then when you multiply it, it goes in, and then you divide it, it goes out.
You said you multiplied it and it got bigger, right?
Bigger?
Okay. So you multiplied by 5 and it got thin. Yeah, it got thinner. So let's try multiplying by a fraction and see what happens. Or by a decimal, as Gracie said. I'm coming. What happened?
It made it bigger. The smaller the number is, the bigger it is, and the bigger the number is, the smaller it is.
Yes.
Is that what I said?
Is that how you say it?
Yes, because if it's 1, it's bigger, and if it's 16, it's smaller.
Nice.
As seen in the previous clips, students often use language such as upside down or flip, bigger, smaller, or skinnier, goes up, down, to the right, or to the left, when first exploring transformations of functions. It is important to use this time of exploration and inquiry to probe students' thinking and have them make explicit connections to the mathematical language of transformations, such as reflection, vertical and horizontal shifts, stretches, and shrinks. A great summarizing task for these types of exploration activities would be to require students to create a graphic organizer, such as this one from the Algebra 1 and Coordinate Algebra unit frameworks. The exploration of the transformations of functions using a graphing calculator or a Desmos calculator coupled with a graphic organizer will help students commit the relationships to memory, ultimately allowing them to determine the transformation of a function by inspecting the equation of the function. In the following clips, students are working on the task graphing transformations from the Algebra 1 Unit 3 frameworks and the Analytic Geometry Unit 5 frameworks. This task works hand in hand with exploration activities such as the previous Desmos activity and asks students to make conjectures about function transformations, in turn helping students solidify their understanding of the connections between the equations of the functions and their corresponding transformations.
Right? Okay. So
It's going to go to the right, right?
All right, you see what she means? Okay, so now notice for this one they were adding. So what do you think is going to happen when you subtract and you do the same thing?
It's gonna go to the right side.
I think it's going to go to the right. All right, put it in your calculator and check it out, buddy.
So since this is a negative x squared, it is going to reflect, it's going to end up reflecting from this side.
because the directions say graph without,
As you can
just
see
by
right here,
using
this is a positive x listed, which caused the parabola to, what's the word I'm looking for?
and then
Okay.
move it up.
And what does the
No,
plus 5
okay,
tell
in the
you?
same spot.
The plus 5 is telling me how
So
the
if I,
parabola
so
itself
for
is going to shift
example,
up.
if I reflect this,
Once students have established a foundational understanding of how the graphs of functions are affected by changing values within the parent function, the Desmos classroom activity Marble Slides can provide a fun context for students to apply their knowledge of function transformations. The goal of this activity is to construct an equation which will cause the marbles to hit all of the stars. As stated earlier, quadratic functions provide good context when introducing odd and even functions as asked for in standard FBF3. GeoGebra, a free interactive mathematics application, provides activities such as this one which will allow students to explore and gain a geometric understanding of what makes a function odd or even. For more information on the resources available through GeoGebra, as well as the resources available through Desmos and the GSE unit frameworks, please see the listing of resources provided for this video.